All right, so picture this. You're trying to hear a single rhythmic whisper in the middle of a roaring stadium, jam-packed with a million cheering fans. I mean, that sounds impossible, right? Well, for astronomers, that's pretty much just another day at the office. Today, we're jumping right into a cosmic detective story, the hunt for a ghost in a city made of stars. And that's really the heart of the problem, isn't it? We're not just looking for a needle in a haystack here. We're looking for one specific spinning needle in a haystack that's made of a million other, much brighter needles. So how on earth do you even start to listen for something so incredibly faint in a place that's so unbelievably loud?
First up, let's get to know our crime scene, a globular cluster. These are some of the oldest, most crowded places in the entire universe. I want you to think of a giant, spherical city of stars, all held together by gravity. They're ancient, they're chaotic, and they are absolutely buzzing with stellar noise, which makes them a ridiculously tough place to search for anything.
And this is our target, our cosmic person of interest. A pulsar is basically the ghost of a dead star. It's this tiny, city-sized remnant that's so dense it's hard to even imagine, and it spins hundreds of times every single second. As it spins, it shoots out beams of radio waves into space, kind of like a cosmic lighthouse. And that pulse, that's the rhythmic whisper we're trying to catch from light years away. Okay, so we've got our super crowded star city and our elusive whispering ghost. To find it, you are going to need a top-notch team of detectives and some seriously advanced listening gear. So let's see how they put together the tools for this cosmic investigation. The team on this case is the Globular Cluster's GMRT Pulsar Search, or, GCGPS for short. Their whole mission is to systematically comb through these star cities, listening for that telltale pulse from these spinning stellar ghosts, especially in clusters that nobody's really looked at this closely before. And every good detective needs their high-tech gadget, right? Well, theirs is the upgraded giant microwave radio telescope. And trust me, this is not your backyard telescope. It is a massive array of antennas, all designed to pick up the absolute faintest radio whispers from the deepest corners of space. So, with the team and their incredible tools all ready to go, the Great Pulsar Hunt didn't just, scan the sky at random. No, this investigation zeroed in on one very specific star city, a prime suspect for hiding exactly what they were hoping to find. And that target was Messier 79. This particular globular cluster was considered a really promising spot to find new pulsars, so the GCGPS team decided to dedicate a specific, really long observation just to listen to this one little patch of sky. Okay, now this is where it gets really interesting. This is like looking at the detective's logbook. They pointed the UGMRT at Messier 79 for 9,060 seconds. That's over 2.5 hours of just listening. And look at that observation mode, phased array. That right there, that's the secret weapon. And that beam sensitivity, it tells us the quietest sound they could possibly hear. We measure this in microjanksies, and the limit here was a tiny 71, incredibly faint. So what is this phased array mode anyway? Well, it's absolutely brilliant. Instead of just using one giant telescope dish, you use a whole bunch of antennas spread out over a huge area. Then you use a supercomputer to combine all their signals perfectly. And what this does is create a virtual telescope that's way more sensitive than any single one could ever be. It's the perfect way to filter out all that background noise and listen for that one tiny whisper. So, the team pointed their powerful virtual ear at Messier 79. They listened past the roar of a million stars. They filtered the data, they searched and searched for a pattern, and then, after 9,060 seconds of intense focus, they got it. A faint, periodic, rhythmic beat. A pulse. Now, hearing this signal is that huge breakthrough moment, but the investigation is nowhere near done. Now the really hard part begins, decoding that signal to figure out exactly what they found. It's time to analyze the evidence. And the evidence was conclusive. The team had discovered the very first millisecond pulsar ever found in the globular cluster Messier 79. Our ghost finally has a name, J0524-2431A. I mean, what a landmark discovery for this particular star city. Let's go back to this number because it is so important. 71 microjanskis. This wasn't just how sensitive the telescope was in general. It was the absolute limit.
The signal from this new pulsar was so faint, it was literally on the razor's edge of being detectable. Any quieter, and it would have stayed a ghost forever. And this is where you really see why that technology was a total game changer. If you just took a standard radio picture of that same area, you could only detect things down to about 112 microjanskis. Well, the pulsar signal was way fainter than that. Without the incredible sensitivity of that phased array mode, this discovery just would not have happened. Simple as that. You know, in science, you answer one question and 10 more just pop up. As the researchers noted in their paper, even though they've found the pulse, the hunt isn't over. They know the pulsar is in the cluster somewhere, but now they have to pinpoint its exact location among a million other stars, and that's the next phase of the investigation. So, finding a single, super faint pulsar is an incredible achievement, no doubt. But what makes this so exciting is what it represents. It's kind of a proof of concept, and it's opening the door to a whole new frontier in astronomy. So let's take a look at where this discovery might take us next. Okay, just look at this contrast. On the left, you've got a radio map from a current survey. You see a few confirmed signals, like little beacons in this huge ocean of darkness. But then look at the right. That's a simulation of all the pulsars we think are actually out there. This discovery confirms we finally have the right tools to start finding them, and it shows us we've really only just scratched the surface. So how in the world are we going to find the rest of this hidden population? Well, we're going to need bigger ears, a lot bigger. The next generation of radio telescopes, like the Square Kilometer Array, or SKA, will be so powerful that signals that are just faint whispers to us today will sound like they're shouting at us tomorrow. And I mean, just look at the numbers here. Today, we found around 345 pulsars in all the globular clusters combined. With the SKA, the models are predicting we could find a total of around 1,700. That's not just a small increase. That is a revolution. We are right on the verge of a pulsar population explosion. And that really is the ultimate takeaway. Every single new pulsar is more than just a discovery. It's a precision tool. It's a tiny natural laboratory spinning out there in space that we can use to test the laws of gravity, to probe the nature of matter at insane densities, and to map the magnetic fields inside these ancient star cities. The hunt for that one ghost in Messier 79 was a huge triumph. But the real question is, what secrets are we going to learn when an entire chorus of them finally begins to sing?